So this video is about my single player tic-tac-toe. So let me just first show you. Now as I can enter a position and it'll set it to X and then the computer will play. Now now let me show you a case where the computer wins, because this thing is unbeatable. Now so I'll put it over here. Oh, there's one. Now let's look at the code. This thing is truly unbeatable. You cannot beat it. Now let me just go to. So first I'm gonna import the random and the math modules. I don't know why I imported the math again, but okay. So self.arr is our two-dimensional array, which is for all our tic-tac-toe things, one by one, all 9 of the spaces. Self.lines is just a useless array which I used for convenience. So it's you'll see what it does later on. So self.first move is the first move. Like based on where he plays the first move, I'm gonna play my move, because or else if it runs the regular algorithm for playing the move, it would just play it in a random position. So I wanted to play it in a specific position for each thing. So we would say self.menu. But before that, let me just show you that it is a little bit longer than 100, but there are lots of stuff which I can easily make it under 100. For example, I can just remove this. I don't really need it. Then I can also do lots of stuff. Like if you can see, this much is repeated twice, so I can just make that into a function. But I'm too lazy. It's fine. So as you can see, I can just make this much into a function. So yeah, but I didn't, and I'm not going to now, so it's fine. Now we're going to do a try catch in case he enters a letter. So first we'll ask for the position and try to cast or whatever it's called to integer. So input, enter position, fine. So accept value error, and you print enter valid thing. And this actually should be self.first move. Yeah. So this should have been self.first move. Then if it's wrong, it'll just call the same function again, so that it'll start from the beginning. Now if the number is less than 9 or the number is less than 1, means he hasn't entered a proper option, which is like, suppose he enters 10 and 10 does not exist on the tic-tac-toe table. So yeah, and so I'll say enter valid option and again call the function. Then if it's a valid, because these two are fine, means it passes those two checking. Then we say do self.set, which is another function I've defined, and num is the number over here which you asked to enter, and x is another what you want to set it to. So let's go to set. So as I was saying, there are a lot of stuff which I can change. I can just club these two together like that. So this and this, I can just club it together. See, there's num over here, num over here, and num is over here, right? So I can just replace this num over here with this. Now let me just explain what this is. Math.fabs gives the absolute value. Now I remember why I imported math of the number minus 1. Now why we do this is because the index in a list is one less than the position while counting, right? So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in a list, the first index is a 0. So that's why we do -1. So, but that would also mean if he entered 0, suppose no, like yeah, I don't know why I just did math out of fast. If he enters 1, it'll become 0. If he enters 2, it'll become 1. If he enters this 3, it'll become 2, like that. I just put the math FABS by mistake. I don't remember why. Now if the slash gives the, so when you divide, you get a remainder and a quotient, right? So the slash gives the quotient. So suppose I have 3 third position. If he enters 3 as the num, then this will output 2. Then num /3 gives 0, which is the quotient, which is the row which you have to enter it in. So for 8 it would give 2, 0, 1, 2, so the third row. So like that. Num /3 gives the row, and the column is num mod 3, which is the remainder. So if both of them are equal to nothing, then we say self.arr of this, and you set it to str, which is this string over here. Okay, and you return true, so that you know it's been set. Else you say self false, return false, so you know it's not been set, because you see why that causes problems later on. Now I could also do one thing. I would say self.get and give the number, which I've defined a function get over here, which basically does the same thing, except it just returns it. So there are a lot of small things here and there which I can fix, but it doesn't really improve efficiency that much. It's just code becomes less. Yeah. So where were we? Yeah, self.firstMove. Now x is equal to self.set. Now if x is equal to false, means it's already filled, you say print already filled, and self.firstMove again, right? And now he's set it. Now you need to set, the computer needs to set. So this stuff is fairly basic. We'll say if number is equal to 1, or num is equal to 3, or num is equal to 7, or num is equal to 9, means he has played in some of the corners. Now the only place to play if he's played in the corners is in the center, because if you play in any of the other ones, he'll definitely win. I'll show you what I mean. Let me open up draw or something. Yeah. That'll load up. Yeah. So if these are, what is this? Let me see how I do this. Here, OneNote works, right? I don't have a pen, so just, even though my computer is a touch screen, I don't have a pen, so just bear with me, okay? For my shabby drawings. Sometimes I don't understand this stuff. God, it's so slow. My computer has a 3rd Gen i3 and integrated graphics. Ha ha ha. Now let me open black. So I'll open the black pen. Yeah. So if this is my tic-tac-toe, and suppose he plays in one of the corners, and I play in the here, suppose. So then he can easily win. If he plays over here, I have to play here, and if he plays over here, then I have to play either here or here. So he won. So that way he won, right? So let me just delete it all. How do you delete it? Yeah. Now if I play in the, suppose I play over here, if he plays over here, we covered these four corners, right? This, this, this and this. If he plays here, I can just do this and here, like that, and he can either play here, so the computer would either have to play here or here. So suppose he plays here, he can play here, and he won, right? Now suppose we covered these four. Suppose he plays in the center, there's nothing you can really do. So that's why the only way to win is tie is in the center, right? So yeah, that's why we play in the center if he plays in the corner. If he plays in the, suppose he plays in the middle, then you gotta play in one of the corners, or else you can just put it in beside it and then do the same, one of the similar things to the corners, or else you just play it in the center. But yeah, because else means the other four side ones, corners, sorry, edges. So yeah, then you play in the center, and then after that you call self.main, which first called self.menu. And by the way, I forgot to cover this, but first move also called self.menu. So in self.menu, you define a random variable called z, and for I in self.arr, which is like the first list we define at top, we print the thing, and then we print self.lines of z. So self.lines is all the lines which go. So you have 1, 2, 3 values in self.lines. So you have three lines, right? So 1, 2 which are visible, 1 is just blank. So it's a pretty neat solution, I would say. And then z plus plus, z is equal to z plus 1. So yeah, after self.menu, what's called in self, we do the same thing, and then we call self.opponent, which makes the opponent play. Self.check checks if the game is over, and then call self.main again. So now we'll just quickly go over self.check, which is the main, which is really easy. So possible is why don't we just skip possible for now, because I'll explain that when first we'll do self.opponent, which is the real deal over here. Couple of for loops, right? Now here, possible is the list of all possible ways to win the game. So here 1, 2, 3. So the top 3 rows 4 5 6, bottom 7 8 9, 1 4 7, down 2 5 8, 3 6 9, 1 5 9, 3 5 7, 1 3 2, 4 6 5, like that. And the opposite way is also, because we need to check if they've played in any two of those positions, then play over there where the third one is. Like suppose he has played in position 1 and position 2, we need to play in position 3 to stop them, right? So it's a really inefficient, or whatever you want to call it, solution, but it works. Now for iron range of 2, which starts from 2 and length if possible, and then step 3. So if the get basically returns the value at that position of possible of I minus 2, which is the first one. So suppose we start from here, so possible of 2 is 3, so possible of I minus 2 is 1, and possible of I minus 1 is 2. So if you solve the get of those, you get the value for each of those. If both of them are O, then you play in the third position, which is 3 in this case. So basically, if the computer has positions 1 and 2, then you play in the third position. So suppose it doesn't work, like if it's not that, if it's already filled, if it's not filled, and if it got filled, then only you return true and get out of the loop. Or else if it's filled, you don't need to care, just continue with the loop. Then after that, you just do it for each of them, and then possible to reverse, it just checks the other way around, like 3 2, if position 3 and 2 are filled, then fill position 1. So you do the same thing again, and then again you do possible to reverse, so that it becomes back to normal, and then you check that for the opponent. So first you check if you can win, then you prevent your opponent from winning. Then after that you do the same thing, you reverse and check, and then you say do self check tie. Check tie does if it's a tie, then so first you say it's a tie, so you say x is equal to true. Now for I and self or for I and j, if j is equal to nothing, then x is equal to false, means there's some empty space, so it can't be a tie. And if it's true, you say self-done menu, print out the final thing, and then you print tie and exit. Now in self-done menu, self-check possible, we saw that before. So for I and range, you can check like that. And if if 3 of the values over here are equal, means if all 3 of them are the same thing, then only if any of them are x or o, like so all 3 could be the same, but all 3 of them could be blank, but they're still the same. So you need to check if they're an x or an o. Then you say print the menu again, and then you say this one has 1 and exit. So yeah, if name is equal to underscore to main, means you're running the program and not importing it. Yeah, that's about it. Thanks for watching. Make sure to like and subscribe, and I'll see you in my next video. Peace.